This video is those of you that have chosen a t-test for your study. So basically you are looking at the averages of a data set and you are comparing it to some type of claim that has already been made by somebody else. So to start off, you should have already watched the videos for sampling and whether or not your test is quantitative or qualitative, which if you've already decided what test you're doing, you've already finished all of that part. So the first part of the math portion of your report should just talk about your question of interest and why you were even interested in this question to begin with. What was it that drove you to do this study in the first place? And how you collected your sample, how did you assure that it was random, and make sure that you provide details in how you chose the people you talked to or how you came up with the measurements that you are using. So I'm going to walk through an example for you of this type of test. So my claim is that the school's track team has an average sprint time of 7 seconds. So this value right here was computed, or someone came up with that on their own. It was not me. This is the school's claim, and what I want to try to do is see if I agree with that claim. So what I do is take a random sample of track members or a random sample of sprints and record those times, and I've done that here. Now your sample size would need to be at least 30 to have a good results in the end. This one is not that big just because I wanted to shorten the video length a little bit. So a lot of my stuff probably won't check out, but yours will. So these are my sprint times, and what I want to do is I want to find the average sprint time and see how that compares to this claim of 7 seconds. So I'm just going to enter my data into MiniTab. This video is going to explain to you how to use MiniTab to set up your report. If you're going to use the calculator to do this, you can. I just encourage MiniTab because it will do everything for you and it will transfer everything that you do into your report if you're working in Microsoft Word. The calculator will still compute what you need, but you'll have to transfer those things manually over into your report, so it's just a little more time consuming. So to use MiniTab for a t-test, the first thing I'm going to do is put my data in. And under C1 in the gray box here, I'm going to name the variable. And the variable that I was looking at in this study was the sprint times for the track team. And then I will just type the sprint time starting with number 1 into my data set. So I'm just going to take a second to enter those values. And you would want to go back and make sure that you've entered everything correctly. I'm not going to take the time to do that now. However, what I want to do is look at my results to see what's going on with my data set. So we're just going to summarize the statistics that we've come up with. So after we've entered it, which is your number 1, number 2, we're going to choose stats at the top of the page. Step number 3, you're going to choose basic statistics. Step number 4, you're going to choose a graphical summary. Step number 5, you're going to click in the empty white box for variable. You're going to highlight the variable you're interested in over here on the left, which is sprint times. You're going to choose select underneath that variable, and then you're going to click OK. Now, this is going to give you a lot of different things. You're going to get a histogram of results. You're going to get a box and whisker plot of results. You have some confidence intervals down here that I can't really see the actual amount for. I don't know about the Danville site. We did not discuss medians, so I'm going to, well, it won't let me just delete that one, so I'll just leave it. But There's a lot of things we didn't talk about in Martinsville here, like we didn't do Arla Anderson Darling. So I'm going to right click on it so that the white boxes just surround Anderson Darling, and I'm going to delete that as well as the A squared row. I'm going to leave the p-value for right now. That might change in a minute depending on what test I do. Actually, that's an Arlington Anderson Darling, whatever that's. I can't remember this morning, but anyway, I'm going to delete that row. Don't help. Okay. We did talk about mean variance skewness. I don't know what kurtosis is, but I would just go through and anything that you don't really recognize or you didn't really talk about. We didn't do confidence intervals for mean. I would delete that as well as the numbers associated with it, just because if anyone asks you questions in your presentation about those values and you don't really know what you're talking about, then it kind of, it's just not good. All right, so this report, all these graphs, you'll see that my mean came out as 6.73, so it's lower than what the claim was that was made by the school. But all of this statistical summary, I can right-click somewhere in the gray area, and you'll notice that you have an option that you can send that graph to Microsoft Word. So when you do that, whatever Microsoft Word document you have up, in this case it's my step-by-step chart, it automatically copies all of that into your report. You don't have to recreate it. You don't have to make it yourself. If you did this on the calculator, you would still have to go into some type of Excel program and do it yourself. So MiniTab just makes things easy. You can click and highlight that and drag it anywhere you want to take it. But also you'll notice that at the end of each section, summarizing statistics for this one, you have a double-starred instructional paragraph that tells you what you need to discuss from this summary that MiniTab has spit out. So you would want to, we use a CUS acronym here in Martinsville. It stands for, we want to talk about the center, which is your mean. We want to talk about the spread, which is the standard deviation. The U is unusual points. Is there anything that may be an outlier that's far away from all the rest of the data? And you also want to talk about the shape of your distribution. Is it symmetric? Is it skewed? We would like for it to be symmetric because we're going to be looking at some normal analysis. But you want to talk about those four things. Oh, and I already typed that there. So just use that paragraph as a guide on what the things that you need to discuss and report out from that statistical summary. Now, what I get from this statistical summary is that I have a mean of 6.7385, and that's lower than what this school initially claimed. They were initially claiming that it had an average sprint time of 7 seconds. So I also want to make a statement right here about what I'm trying to prove. So I think that the sprint time is actually less than 7, because when I did my sample, that's the result I got. I got a number less than 7. So my question is my result 6.7 just random sampling variability? If I took another sample, maybe I would get 7.1, or maybe I would get 8.1. I don't know. Maybe it would be different if I did this sample again. So our inference is going to be looking at, is this low enough where I can say this school made a false claim? And what we're going to do is run a test for that. So before we can run this inference, we do need to check the conditions. Number one, we have to have a random sample. And if you've already taken care of that when you collected your own sample, that should be covered and should already be explained in your introduction. We have to assure that our data set is going to be normal. If you have chosen a sample that is greater than or equal to 30, then you can already make that assumption. There's nothing else that you need to do. I would get a sample of 30 just so you don't have to run it. Now, if you don't have a sample of 30, you will need to go to the normal probability plot in your calculator and make sure that it appears linear. But again, if you have a sample size of 30, that's all you need to check normal. Your 10% independence condition, you're going to take your sample size, which in this case is 13, multiply it by 10. 130 would need to be less than my population. Okay, and for yours, if you have a sample size of 30, then 300 would be less than your population. So for my data, then I would have to assume that I have at least 130 people, or at least 130 sprints that are happening on this track team, and I can definitely assume that they are running more than 130 times over their career. Okay, so in your Word document here, you're just going to make a statement that all conditions have been met, so we're going to continue with the test. If your conditions are not met, then you're going to need to adjust your sample size until they are. So now that conditions are met, let's run this significance test and see what happens here. I've already copied this summary, this graphical summary, over to my report, so I'm just going to X out of that and get that out of the way. So step number 1, we're going to go to Stat. We're going to choose number 2, Basic Statistics. And then number 3, we're choosing a one sample T test for means. And number 4, we're going to choose one or more samples each in a column from this drop-down menu. Mine is already there, so I'll just leave it. And then I'm going to click in the empty white box. Step number 6 tells me to highlight the variable and select. So I'm going to highlight sprint times over here on the left, and then click the select box underneath it. And what I want to do with this variable is perform a hypothesis test on it. So I'm going to check the box beside perform hypothesis test. The hypothesized mean is going to be whatever claim that you were comparing this to. So the school is claiming that the average sprint time is 7. I'll type that in there. And then we'll click the options button, step number 9. You'll want to enter your confidence level, which is typically 95%. We'll talk about, how we could change that in a future video. And then I want to choose my alternative hypothesis. So because I got a value that was less than the 7, I'm going to run a less than hypothesized mean and try to prove that the sprint time is actually lower. If you wanted to just test to see if it was different and not give it a direction, you could also use the not equal to. All right, so I'm going to run this, hit OK on this box as well, and it's going to spit out a test for you. And just like with the graph, you can right click up here beside summary report for sprint times. Actually, I want the one sample T test I just ran. So I'm going to right click right beside one sample T, and I'm going to send that to Word. And again, it sends that whole report into your Word document. It sets up your hypothesis for you. It spits out your T value. It spits out your P value. And what I want to take from that report is I want to make, well, it's down here. Right here, and it's actually under your confidence interval. In your Word document, you're going to write your conclusion. You're going to link it to the p-value. So if your p-value is less than 0.05, and 0.05 is an alpha level that is associated with a 95% confidence level, those two numbers should equal 100% together. If that p-value is less than 0.05, you're going to reject the null hypothesis. That means you do have evidence of the alternative. And if your p-value is greater than 0.05, you're going to fail to reject the null hypothesis. You do not have evidence of the alternative. Okay. So for this particular test, and I'll just type it up here instead of trying to move everything around, My p-value was 0.32. So my conclusion would be the p-value is equal to 0.232, which is greater than the 0.05 alpha level I was testing at. So I will fail to reject the null hypothesis. That means I do not have evidence of the alternative. And in this case, the alternative that I was trying to prove was that the sprint times are less than 7. So I do not have evidence that the sprint times are less than 7. Now, once we've made our conclusion, we can use a confidence interval to support that conclusion. Notice that the test that you ran here did not spit out a confidence interval. That's because confidence intervals require a not equal to assumption for the alternative in order to compute it. So you'll notice that your confidence interval steps here are the exact same steps as you did for running the test. The only difference is that the alternative is going to be a not equal to claim instead of a less than claim. Now, when I run this, it's going to change my p-value, and I don't want to use the different p-value because what I was interested in was the less than alternative. But I do want to go back and get this confidence interval. So I'm going to go back to stat, basic statistics, one sample t. You'll notice that your variable is already in there. Your hypothesized mean is already in there. You just want to go to options and change this alternative to a not equal to. So this time when I hit OK, you'll notice that this confidence interval pops up. It changes your p-value. I don't want to use this new p-value. That's not what I was testing, a not equal. So I'm not going to copy this whole report over to my Word document. I'm just going to right click right on top of that confidence interval, copy it, and then I can come over here and just paste that to my Word document with the report. Okay, so what this confidence interval says, and I will come down here, that last part of that conclusion paragraph, we can use that to support our test, and I've given you kind of a sentence frame right there for that. So I'm going to say we are 95%, since that's the confidence level I was testing at, we are 95% confident that the interval from 5.986 up to 7.491 captures the true population mean, or the true mean of the sprint times for this school. Okay, so how does that support my conclusion? In my conclusion, I said that I do not have evidence to support that the times are less than 7. So if I don't have evidence to support that, then I don't think they're less than 7. The school is probably accurate in their claim that the sprint times are equal to 7. And if that's true, then 7 should be in my confidence interval, and 7 does fall between 5.9 and 7.5. So that confirms for me that the conclusion I made is accurate. All right. Now, once you've done all this, you will need to do a final paragraph, and that's going to be a separate video. Before I explain that, though, if you're doing this with the calculator, you can run the test and everything with your calculator. Graphs you'll have to do on your own. The calculator will do the graphs, but you're just going to have to transfer them over anyway. So that's why I like MiniTab so much. The test can be run, though, if you go to Stat Test and choose a just a t-test, number 2. It's not going to say one sample. If I choose number 2, it's going to ask me if I have data or if I have stats. In this case, I have data. The stats have not been run on it. I just have a list of numbers, and that's what you would have in your study as well. So I'm going to choose data. It's going to ask me what the null hypothesis is. We are assuming right out the gate that that is 7. And then it's going to ask me what list I have put the data in. So we're going to have to go to stat. We're going to have to choose edit, and we're going to have to put our data in a list. So you would go same way we did in MiniTab, and you would just type your numbers into your calculator. And again, I go back and check them if you're in a hurry. I'm not going to check mine, so hopefully I haven't mistyped anything. Once you get it entailed, want to go back to stat test. Again, choose your t-test, number 2. We've put in our null of 7. Now our list is in L1, so it's pulling my data in. Your frequency should already be 1. It'll stay that way. And then you're going to choose the alternative you were trying to prove. We were trying to prove that our result was less than the null hypothesis, and then we will calculate. So it does give you the p-value of 0.227, which is a little different than what MiniTab spit out, but maybe I typed something wrong. But it will give you that p-value from that test. You can also run a confidence interval. If we go to stat, test again, and scroll down to t-interval, which is number 8, you can put data in L1, frequency of 1. You want your confidence level, which is 95%. And then calculate, and that will give you your confidence interval as well. So you just don't have a way of transferring this from your calculator to your Word document, but you're still going to write your conclusions the same way. That is no different. Now, I'm going to do a separate video for this last paragraph since this part's going to be the same for everybody. That way I only have to make one video. So make sure before you wrap up your report that you do watch the final video on errors and alpha level.